Partial fractions. Two or more fractions that can be added together to make one fraction are called partial fractions. Add these two partial fractions together to get one fraction. Well, we know when we're adding fractions we need a common denominator. And that common denominator here would be x minus 2, x plus 1. Now, let's think. The top of this needs to be multiplied by x plus 1 because that's what we multiplied the bottom by. So we're going to get 2x plus 1. Then we've got the plus sign, which is this plus in the middle here. And the 3 here needs to be multiplied by x minus 2. And so we've got x minus 2, x plus 1 on the bottom. And then we've got 2x plus 2 plus 3x take away 6. That gives us 5x take away 4 over x minus 2, x plus 1. The point of what we're doing here, however, is that we want to take this and we want to turn it into the partial fractions. So, going in the opposite direction is called partial fraction decomposition. There are 3 decomposition patterns we need to be aware of. Type 1, that's where we have linear factors only in the denominator. An example would be this one, x plus 3 over x minus 2, x plus 4. I'm just going to point out here that for all of these types, type 1, type 2 and type 3, the highest power in the numerator is going to be less than the highest power in the denominator. In the denominator here, if we expand out, we get an x squared. Here we get an x to the power 1. That's called a proper fraction. Now, when you have the linear factors only, you can decompose into a constant a over x minus 2 and a constant b over x plus 4. And the example that we did just now is one where we had linear factors only in the denominator, and we got there by adding something of this type. And this is how each of these forms is actually derived, just by looking at what happens when you add these types of fractions together. So, a linear factor is always dealt with by a constant over that factor. Type 2 is where we have a quadratic factor in the denominator. So the example I've got here is x squared minus 3 over x minus 1, x squared plus 1. The x squared plus 1 being a quadratic factor. Note the linear factor is dealt with in the same way as up in the type 1. That's how we always deal with linear factors. But note the quadratic factor. That's bx plus c over x squared plus 1. So that's how we deal with a quadratic factor. Type 3 is where we have a repeated factor in the denominator. And if we look at this example here, x minus 1 over x plus 1, x minus 2 squared, the x minus 2 squared is a repeated factor. Note the linear factor x plus 1 is dealt with in exactly the same way as before. The next two terms deal with the repeated factor. So we get b over x plus 2 and c over x minus 2 squared. And if this was a higher power, like a 3, we'd just have another term on the end like so. Many texts that you'll come across will mention type 4, but in practice this is simply an improper fraction. Remember, I mentioned before about these are proper fractions because of the power on the top and the power on the bottom. And in this case, after division, that becomes one of the other types. So a type 4 will just require an algebraic division, and then you'll get some sort of quotient and a fraction that will be one of the previous types.